Welcome to my channel. In this video, we are going to discuss the basics of electronics. The content is as follows: conductor, insulator, semiconductor, electronics, electronic circuit, active and passive components, current, voltage, resistance, power, AC and DC, AC source and DC source. Insulator, conductor and semiconductor. In this video, we are not going to discuss any concepts, just it is a revision. All information is brought in one video. Insulator is a material whose internal electric charges do not flow freely. Very little electric current will flow through it. Conductor means what? It allows flow of charge. Semiconductor, it is in between the conductor and an insulator. For example, it is in between the copper and we can say glass. In conductive materials, no band gap exists. You can see the conductor. This is for a semiconductor. Band gap is very less. For insulator, band gap will be very high. What is electronics? It is a study of how to control the flow of electrons. It deals with the circuits made up of components that control the flow of electricity. Electronic circuit is composed of individual electronic components such as resistor, transistor, capacitor, inductor, etc. And all these are connected by a conductive material or a wire. These are the electronic components. Electronic component is a physical entity in an electronic system used to affect the electrons. And these electronic component we are going to classify into two. One is the active and there is a passive. Active components which require external source to their operation. For example, transistor, op amp, SCR, IC, voltage regulator, etc. Passive components which do not require external source to their operation. Resistor, capacitor, inductor, etc. These are the capacitor, inductor, resistors. Active components, you have a transistor, ICs. Devices which uses a piezoelectric effects comes under electromechanical components. In many books, in many websites, to discuss the voltage and current, they give a water analogy. Water is flowing in the pipe, so size if you reduce, pipe is narrowed down, then automatically there will be a pressure. It is nothing but a voltage. The flow of water, what we say, it is nothing but a current. Voltage is the difference in charge between the 2 points. Current is the rate at which charge is flowing. Resistance is a material's tendency to oppose or you can say resist the flow of charge. Analogy, if I have water tank, amount of water in the is nothing but a charge and water pressure is nothing but a voltage and water flow is nothing but a current. Voltage is measured in volts, current is always measured in amps and resistance is measured in ohms. 1 ampere is defined as, try to remember, 6.241 into 10 raised to 18 electrons per second, or we call it as a 1 coulomb through a particular point in a circuit. 1 volt is the energy consumption of 1 joule per electric charge of 1 coulomb, or 1 volt equal to 1 joules per coulomb. Ohm is the resistance between the 2 points in a conductor where application of 1 volt will push 6.241 into 10 raised to 8 electrons. We call it as a 1 ohm. Ohm's law, I equal to V divided by R. V is a voltage, I is a current, R is a resistance. provided the area of a cross section and the length and the material of a conductor and temperature remains constant. To find a voltage, we usually multiply I into R. Ohm's law do not apply to most of the semiconducting devices. This is very important because they are not linear. Hence, we cannot apply Ohm's law. We can pause the video. We can rewind, try to understand the basics. Power is the rate at which electrical energy is converted into another form, such as motion, heat, etc. Power equal to V into I, or power equal to I square into R, or power equal to V square by R. Two types of currents are there, alternating current and there is a direct current. DC flows in one direction. AC electric charge changes direction periodically. Not only current but also the voltage reverses because of the change in the current flow in case of AC. So AC source and this is a DC source. AC means is having a 50 Hz. Frequency of DC is always 0 Hz. AC safe to transfer over a longer distance. DC cannot travel very far until it begins to lose energy when distance is very high. All equipments like computers, radio, mobile phones, etc. Electronic equipments uses all circuits inside. All these uses a direct current, but we use the AC means to power all these. Though inside this AC is converted into DC. Solar panels used to generating electricity usually gives a DC current. Hence, we use an inverter to convert DC into AC. And AC and DC both are used in electrical and electronic industries. Each is having its own advantages as well as disadvantages. Which gives a better shock, AC or DC? Low frequency AC can be more dangerous than high frequency AC. And it is 3 to 5 times more dangerous than DC. So this is collected from the internet. Similarly, if a DC gives a shock, they are unable to pull their hands back because of DC current flow is continuous. Potentiometer. Consider 500 kilo potentiometer. The resistance between 1 and 2. This is a 1, this is a 2, and it is a 3. The resistance between the 2 and 3 and resistance between the 1 and 3. Give the answer. 1 and 2 is 0 to 250 K. 2 to 3 is 0 to 250 K. 1 to 3 is 0 to 2. No, it is a fixed 500 K. Closed circuit is a closed if the circle is complete, if all currents have a path back to the where they come from. Open circuit is opened if no current flows. It breaks the flow of current between the power and the ground terminal. The summary, whatever we have discussed so far. These are references. For more information, visit these links. Thanks for watching this video. Share this video if you like. Subscribe this channel. Thank you.